he mentioned some of it, B-sides. We ordered T-shirts again. Whether or not it'll be ready is a good question.
Red T-shirts.
Shirts.
Yeah, if you're thirsty, have another
Thank
one.
you, Google. And then we're always looking for other venues as well. We recently had it at Prodigy Finance, which was great. Just because remember that a WASP is a NGO, and we don't want to show favor to anyone, if I could put it that way. I mean, Voss has been a gracious host, but it does look like we favor a company over others, which is against kind of the ethos of WASP. And then we want to do lightning talks every now and then, because a talk does take a long time to actually prepare, and lightning talks obviously a little bit, not a deep dive, just a little bit of what you've been doing, and if it's interesting, and always give us feedback. Actually, we don't actually know if we're doing a good job. We've just been doing this for 3 years, because why not? And then if you want to join us, I'm doing the Evil MSc next year. He's busy with it. He's finishing his master's, and my brother's MIA. So, you know, we could always use another hand or two. And I'm a lunatic who's been messing around with infrastructure for a while. Notable things I've done: trashed the Elasticsearch production cluster with 700 gigs worth of data, and got it back with 200 in an hour with snapshots. So I am insane, but I do love security. And for 9 months, I worked on an AWS infrastructure, which was already built. So I had the opportunity to go look at what could be improved over the time, instead of just throwing more services and just being like, we don't care. I'm DevOps. I'm supposed to help the devs, not think about security as well. And I'm busy with Google Cloud now as well, so I'm doing a little bit of AWS, a bit of Google Cloud, but this is obviously AWS focused. And to start off with, it's a cloud. Everything's public, even if you think it's not. Amazon does some really interesting things to segment certain services out of the public internet. But one of the first things you actually realize is, if anything's new at AWS, the only routing they have available is out to the public internet from their own networking. So generally things are all public, but it might be encrypted, it might be HTTPS with authentication. It's not like Mongo that gets spun up with default everything's open, or Elasticsearch does the same thing. So always assume that you should secure everything. Everything should be encrypted. And some things are easier and some things are harder. So if I could summarize a cloud, it means there's an API to spin up VMs. So because it has an API, it gives you power, but it also opens you up for attack. So the general scenario that I had was a Python API, or a couple actually. Some serverless APIs, so both Google Cloud and Amazon, and I think Azure now as well, have it's essentially a container environment where you just upload the code, and your dependencies and how it runs is up to them. So you don't provision a VM, you don't provision anything, you just make sure that your code will run, and they will run as many containers as necessary to fulfill your load, which is somewhat limited. It's per IP, for instance, so you need enough in the subnet to actually run, 9,000 parallel containers, stuff like that. React.js front ends. And then we started out with Celery, but before I left, we were rolling out Apache Storm, which is also just a kind of asynchronous work system. Twitter uses it quite extensively, processing large amounts of data. So the API was serving processed data, and we had a lot of incoming actions and things we had to process. And What made it somewhat difficult sometimes is that a lot of our clients were overseas, so the times were odd, and you had to think about how long something loads in different parts of the world, as well as the security, because obviously Amazon security gets complicated across regions because it's outside of their data centers. And then office in Cape Town, some services had to be only staff viewable. So if we were working on a new service or a new front end, we'd want to lock it down to our public IPs so that our competitors aren't looking at what we're doing before we even release it. We had SQL and NoSQL in-memory stores, Elasticsearch, DynamoDB. If there was a game for how many AWS services you could use at the same time, we were probably top 10. The one thing that helped us a lot is that most of it was stuck in one region, which is generally when you start with AWS or Google Cloud, they default you to some region and people don't tend to move out of it. Also because most of the services will be focused in the first region they built. So roll out all the services in one region and then periodically into others. And then we used a lot of Amazon services which you might never have heard of, just because it's a cloud thing. And then my favorite thing in the world, a blog running on WordPress. So secure environment and WordPress, which was never updated, never really looked at. And no one.
That's what you always do with a blog, though, right?
Yes, and everyone forgot what the admin password was. So it is there.
Yeah, but you're sure to get into it.
So effectively, it's an archive of old blog posts.
So what you do with WordPress is you go, not my responsibility.
Mm.
But there is a way to still get away with that, because it sounds like not my problem. So secure, it's not that. Because it was a startup quite recently, everything was done quite quickly. So some things, the guy that I kind of took over from the CTO, he had security in mind, which was great for a starting point, so everything wasn't broken. But at the same time, things need to get done because the CEO was looking for something. Development over DevOps, development over, proper infrastructure sometimes, hard coding credentials. And it's the nature of a startup. We need to get everything out there, otherwise we're not going to make money. So then the question is, what can I do after that? Can I, while we're not certain whether we have been compromised yet or not, can we fix this and quickly? The pros were VPCs. I should have actually done a quick survey. Who works at the cloud at all? Okay, it's a virtual network. Easy. Subnets, SSH keys, and IAM roles were fairly well protected and managed. So IAM role, identity and access management. So every user, all the devs, the testers, a lot of people had AWS accounts, but each one had a different kind of account. So I had a kind of like guard mode account with the CTO, and then everyone else had a more granular, you only need S3, you only need front-end kind of things, or you only need back-end dev kind of things, and lots of monitoring. So the monitoring was CloudWatch, which is Amazon's built-in monitoring, some SNS notifications if something broke, and then Elasticsearch is great for monitoring with Kibana and Logstash. So you just chuck all your logs into Elasticsearch and then start looking at Kibana, building dashboards. So we had dashboards, clients using us across the world, so circles on a map where lots of traffic was coming from. So you could do the typical US thing of like, oh look, there's IPs in China and Iran, so we're probably under attack. when you read Amazon's documentation on securing, they talked about shared responsibility. Because it's a cloud, they try and make it as easy as possible for you to get services built. But to do that, they need to have defaults that are good enough, generally speaking, for you to be secure by some standards, but it isn't 100% secure. And they've got this model of what they take responsibility for, and you'll see it's quite heavy on the top, but generally all their services are encrypted over HTTPS. They secure as much as they possibly can. A good example is Redis and Elasticsearch that they host themselves that you don't host. You don't have all the features because some of the features are web-based, and if people just start scanning, they take down all your infrastructure. If there's a slight flaw in Elasticsearch, which Amazon doesn't have control over, so they lock down some of the management features. So it's pretty much the same as working with any infrastructure, is that you're going to have to try and protect the customer data. Your code and your platforms have to be secure. You have to manage access to them, the keys. You need to do patches. So Amazon does build patching systems and stuff, but they can't just go and patch everything because they could break some of your infrastructure. But one of the good things that they do is if your infrastructure gets too old and they decide to move it, they're just going to move it. So it forces you to keep up to date to some extent. So you have a VM that's 2 years old, and they need to physically move the VM to another physical server. They will switch it off, and they'll warn you about it, but it's going to happen. So if it's Redis, you better be moving that very quickly. Get all your data off. Your in-memory store is not going to survive. So a lot of kind of what I worked on and what I looked at is from a great talk at OWASP's AppSec. I think it was the US AppSec by Coinbase. Anyone know who Coinbase is? So I think by market cap they used to or still are the biggest Bitcoin exchange in the world. So Bitcoin and cloud. So obviously security was a major concern for them. And they have a great talk where they talk about they used to be engineers at NASA's Jet Propulsion Laboratory, and AWS and NASA worked together to build a secure cloud, which they now use for their Gov Cloud and those kinds of infrastructure. And all the things so not just what AWS did to make it more secure, but what they did. So their whole CI, their DevOps, they've got a security team that audits all their containers, all their code. They run regular scans. So that's just their website. So obviously it's important. I think they've actually been hit by a hack as well. So they're not perfect, but they at least have a plan to work with security. For instance, no dev can push code directly to one of their production servers. It all has to go through CI. It all has to go through a process, and it all gets audited, at least in theory. So some of the things that I took away from that, I'll kind of cover now. And by the way, if you want to stone me if I do something or say something wrong, we don't have stones, but we have bottles, and then you are allowed to ask questions while I talk. So this is obviously very difficult to see, but AWS's security, how you manage it is quite important because they have literally a ton of services connected to it. And a lot of those services cost money. So forget about losing your customers' data or leaking things. The fact that someone could spin up 200 very expensive VMs with a graphics card could cost you a ton of money. And if you manage any kind of cloud, just the normal operating costs, because you forgot 5 VMs on for 2 days, gets astronomical quickly. So the first thing to kind of like look at, and that helps you a lot, is the identity and access management. So who's ever heard of people leaving their AWS keys in GitHub?
I've done that by accident.
Shame.
Yeah, shame on me.
Anyway, so Amazon actually...
They have an automated system that trolls people.
They do, yeah.
They have. But on top of that, they now have a system that pushes those keys, if you've selected it on a VM, automatically to the machine. So they've done as much as possible for you not to leave it in your source code. All their libraries and their console and everything's kind of geared towards that. You've got two-factor authentication. IAM can be applied to services, to networking. Imagine it as if you're building an API, because Amazon has an API for everything. They have very granular rules of how you can access that API, but also the networking and the services, and you can even monitor access to IAM via CloudTrail, and changing credentials is also important, because obviously once it hits GitHub, and even if they discover it, you still have to change those credentials, and they keep track of how long credentials have been out there. I'm not going to talk through everything, because I realized that I was putting too much into the slides, but Amazon's got networking and subnets and security rules, aka firewall rules. So Elasticsearch should not be connected to the open internet. Redis should not be on the open internet. MySQL shouldn't. So lock them down. Back to the WordPress instance. Put it in a different region with different rules and different networking. That's step one of having it away from your actual infrastructure. And the same thing can be done with dev, QA, and prod. You can have different organizations with your AWS accounts. You can segment everything as much as possible to protect yourself and isolate things. That's kind of important. Having a subnet just for Redis, a subnet for MySQL, a subnet for Elasticsearch, and a subnet for the API, and then you have routing so that the API can get into all of those, but they can't get into each other. So that you manage exactly the way that you imagine your infrastructure to work. Generally, everything is whitelisted, so think about how you actually want things to work. So it's not working, okay, cool. I forgot about that route, add the route, now it's working. But it doesn't mean that you added every route, every security, every firewall rules open. I've mentioned the VPC endpoints, or if Amazon releases a new service, you can have it route directly into your networking. So instead of having to go out to their external switches and routing, they have intelligent routing for that. But something like DynamoDB, which is very recent, only got it a year later. So then you have to remember that you need to be careful with your credentials, and that it's probably going to hit the public internet at some point. Same thing with Lambda. If you don't set up Lambda in the right way, the networking is pretty much internet-based and not hitting your services, and then you have to set up complex gateways and things to protect you from just opening everything up. Internal DNS is great, not just for security, but for dev. If you happen to delete Elasticsearch, internal DNS makes it very quick to get back online. But if you've hard-coded 3 IPs everywhere in your code, grep -r-e, it takes much longer than it should, over 20 VMs. And then internal DNS also allows you to control, to some extent, how things connect to each other. So if you're trying to connect services to each other, but you don't want anything outside of the load balancer or outside of your network to connect in, they can't use that DNS because it's inside of that network only. And here's where it's starting to get more interesting. So months ago, we bought a desktop PC. It was heavily overpowered, but we installed pfSense on it, not as a VM, just straight up on the machine, connected it to the fiber router, and set up firewall rules. We set up OpenVPN first, So everyone outside of the office could VPN in and be on our own network. And then what we did is Amazon has great, fairly easy to set up functionality for IPsec from your office and a public IP into their networking. So as long as someone's on the VPN or in the office, they've got not free reign, but pretty good routing into Amazon's network, as long as you've allowed it in the firewall. But this versus having a jump box that never gets updated, everyone having a SSH tunnel in to get to services worked out a lot better. Having to tell a dev, oh, you can just ping directly to the IP instead of set up your SSH tunnel and then do things. Eventually, this kind of security actually makes their lives easier, and they warm up to the idea of you're actually going to lock down the environment. And this is kind of how, if you had to visualize how it works. The great thing about this was when I started there, I had a look at all the firewall rules, and I noticed there's not DHCP, but say again? Dynamic IPs from everyone's ADSL in the firewall, and that they're so full that I couldn't add any more. So by having a single IP allowed in, okay, so I have to mention you have services connected to the public internet, so they would still talk out, but internal services that we only want to connect from our public IP or our LAN, the routing worked out perfectly because I could remove all those stupid IPs. And yes, the chances of someone finding that IP and your infrastructure is small, but I sleep better at night, removing all that cruft and knowing that it's locked down a lot more, because you lose track so quickly. And from an Amazon perspective, this is how they envision it. So you could also imagine that instead of having a customer network, you could have a data center. So you could have an on-prem and a cloud, and everything's over a VPN connection. And this is also important because how do you secure Amazon across regions? How does Netflix do that kind of thing? Is they have to set up VPNs. Even if you do cross-region replication with MySQL hosted by AWS, you have to set up basically a VPN connection for it to happen, because otherwise it would just run out into the internet and it's free game. And the best part then was, because we had a public IP, we could go and with IAM actually say, deny every action on our API. So this is creating users, accessing services, listing services, doing literally anything. A general rule was deny it if it's not from our IP addresses internally or the public IP. So then you're already locking down AWS CLI, like what's the DJI, the drone company recently I got nailed again. That kind of thing, you're already protecting yourself quite a lot from that, because you know these two and people know how to use a VPN. So that was a great thing to implement. It had some weirdness sometimes when two IAM roles side by side, one takes precedence and you have to kind of debug that, but generally it works quite well. Back to the drone thing, S3 bites everyone all the time. Amazon recently in their front end put a thing saying public, so that you know that S3 is a network storage. So the thing with S3 is that you can host a static website off network storage as well. And that's where people tend to screw up, because they go, oh, I'm creating a new S3 bucket. I can't remember the permissions. Oh, you can copy permissions from another bucket, and then you get the public one as well, or you just didn't look. So you'll be surprised how many companies have. The CIA got nailed by this recently. Lockheed Martin, I think, got nailed by it as well. So before I left, I did another audit and just looked at which buckets. So log bucket should not be on the public internet. The document bucket should not be on the public internet. Only the React front end should be on the public internet. And even if they're on the public internet, they should be behind our CDN as well with HTTPS and everything. Everyone following up till now? Is it madness? Is it... Anyway, DevOps was a huge help in most of this, because if anyone's managed AWS infrastructure, looking at that console drives you nuts, and you tend to forget how you set something up, routing and NAT boxes and things like, oh, they're going to move it off AWS's infrastructure onto our other server. Shit, we need to move this, or clone it. Okay, clone it, spin it up, nothing's working. What the hell? Oh, routing. Someone put an IP in here. And everything on Amazon's DHCP. Good times, you know. So DevOps, especially if you go look at Packer and Terraform. So Packer is a JSON file. It's kind of like, what's the VM thing from HashiCorp? Vagrant and Docker Compose. It's a JSON file that describes exactly what has to be in your Linux VM instance. So it's repeatable. So let's say every 3 months you decide, I want to build a brand new template for my API server. It runs, it does all the upgrades, it boots up a VM in Amazon, SSHs in, drops scripts in, does all your provisioning, and it'll tell you if it fails. So you can do all your upgrades, everything. You know that template for the VM is solid. Then Terraform is infrastructure as code. So not JSON, but they've got their own kind of syntax. So you say, this is the VPC I want, this is the subnet I want, this is the security group I want, the firewall. This is the S3 I want, this is the VM I want. And you can put it all together in one bunch of pieces of code, and you can, once it's up in the cloud, you can destroy it. You can check whether your state file, which it creates when it creates everything, is the same as the infrastructure. So when that one guy thinks he's a sysadmin, goes and like swaps things around, Terraform goes, whoa, you know, this is wrong. So it's like some of the ideas of Ansible on steroids for cloud. So it covers AWS, Google Cloud, Azure. It's beautiful.
Is it generic between all three?
It supports.
No, so that's the only problem. I think it's called a provider, or they have a term for it, but it's basically a module for each one. So they even have modules for VirtualBox and VMware OpenStack. So generally the ideas can be transferred, but the wording of the modules and stuff are all different. So
it has to interact with each different API.
Yes.
Right? Yeah, exactly.
So it's an API client that uses infrastructure as code syntax to fire up whatever you need. But it's better for me than Ansible. So Ansible is great if you're firing up a Linux VM. It's done, and you want to SSH in and set everything up on the inside. But Ansible is not good for whatever's outside of that VM, because the APIs change too quickly and the modules in Ansible don't.
But isn't Ansible more comparable to Packer?
Yes.
Because Ansible is not
somewhat.
infrastructure as code. Ansible is.
But people tend to write modules like it is. So there's an AWS Lambda module, and there's this module and that module. And when I tried using it, I had to use execute shell commands with AWS's own tools to do the same thing I could do in Terraform.
Sure, I just don't think that Ansible was ever designed to be infrastructure as code.
Indeed,
just
but
because people are
if you go look at the modules that people built for it, they're Frankensteining it.
Yeah, sure.
So generally, what Dean and I, because I had a colleague who did a lot of the DevOps with me, what we kind of went with is Packer, Ansible, Packer, Terraform, Ansible. Packer to build the VM template, Terraform to put it in place with the networking, repeatable, Ansible to make sure that the application's up and running.
Yeah.
But AWS also has other ways of doing that, like user data, which is a script that runs as soon as the VM starts. So you could do a git clone in there if you really wanted to.
Or cloud in it. Right?
Yes.
Yeah.
So I think that comes from the Ubuntu,
Yeah.
so that I don't drag on too much. HashiCorp Vault is a key management API.
Screen.
So I was talking about those hard-coded credentials. Library, call this key, a encrypted key gets sent over decrypted and then put into memory instead of having a file on the VM. That kind of speaks for itself. Then I kind of looked at what...
What's the encryption was it sending? AES? Where did you store the keys for that?
Can't remember. I haven't used it enough. I tended to, because we were using a lot of AWS, I tended to look at the AWS stuff first before we brought in a third-party kind of thing. So for that, Amazon has what they call AWS Key Management Service. So for instance, Lambda, because it's not a machine, the rules for it are different. It's some containers. So what they did allow you to do is, if we had API keys that we needed to use, you encrypted it with AWS's key management service, and it did it automatically. And then as soon as the container started, it injected the keys in and as environment variables in RAM. And as soon as it died, it was gone. And yes, RAM's not totally secure, but I prefer RAM over a file that everyone shares around and VIMs in. What I really enjoyed about AWS, which they made much easier, is the certificate manager. So when I was reading up about it, I actually came across a Let's Encrypt page, a forum where they were saying AWS basically took some of the ideas of Let's Encrypt and made it a service. So for instance, your load balancers, your CDN, everything has access to the certificate manager. So you just go drop down that certificate, and now whatever's hitting you, you don't need to push a certificate to every VM, to every Nginx. It's done for you. If you get into web application firewalls, they've got one that's fairly reasonably priced. It helps DDoS and strips out things like SQL injections and stuff like that.
So you don't need Cloudflare then? Is that them ripping off Cloudflare?
Okay, so they kind of compete with Cloudflare a little bit. So they've got a thing called CloudFront, which is a CDN, and then you attach the WAF to CloudFront. So you have to remember that Cloudflare's kind of infrastructure and business model is completely different. So they give you a CDN that also has DDoS protection on it. And the DDoS is somewhat different. They kind of share the network load over the network, where the WAF kind of just starts killing off connections from the same IPs over time. So it's not quite the same thing, but if you want a quick and easy point and click WAF and CDN, Amazon does it pretty reasonably. CloudWatch is great, logging, and they've got a trusted advisor service as well. I'm not going to go into that now. Oh goodness. Anyway, I'll tell you what's at the end. So Keegan actually showed me this, and this is quite amazing. If you actually want to get into practical learning about Amazon security, it's called flaws.cloud, and the guy went and set up an Amazon account with S3, some VMs and stuff, and just using Amazon CLI, which is their standard tool that you just download to use the infrastructure, you can actually get into a simulated company's documents, and then every step in the way you have to find some string or decrypt something, and then you get deeper and deeper into the infrastructure, which is, if you read what the guy said about the Chinese drone company, is nearly pretty much the same process that he followed. Started with S3, and from there got more and more access. And because it's all an API, if you've got some access, you kind of like escalate it, going through services, seeing where you've got access. And I think a lot of you were here for ThinkStalk, which was pretty much about that. Then Scout Tool and Prowler and Security Monkey are tools to actually scan the infrastructure that you have. Prowler is pretty much a Python tool that just looks at stuff like S3, your IAM. So it's using Boto 3, which is Amazon's library to access their services, and runs through it and looks at the kind of permissions that you have. It'll give you a general idea. Then if you love Netflix like I do, not just the Netflix and chill, but the actual open source that they do. Sometimes I'm funny, not just insane. They write some really cool tools. So they have a tool called Chaos Monkey that switches off VMs and containers. Security Monkey goes through their infrastructure and gives you a web dashboard of what needs looking at, what is to open, what is probably already compromised. And then at the bottom, I'll just tell you what it is who's ever seen a WASP Zap? So Burp Suite is sort of the proprietary. If you've seen Burp Suite, it's a similar kind of thing. It's a vulnerability scanning tool, and the great thing about it is that you can set it up as CI. So Salesforce does this quite well, where in their cloud they allow people to write third-party apps and you can buy them. But what they do is they scan the third-party apps using a WASP Zap, and basically they've got a bunch of vulnerabilities that they just run through and get a report. And if there's any sort of discrepancy, then they will have someone go look at it manually. But it allows a repeatable check on, for instance, if you found a vulnerability and already patched it, to not see it again. Essentially what CI is. So that's what Security Monkey looks like. A nice dashboard tells you, so you probably won't be able to see all of that, but it's saying S3.
Are you targeting that fraud?
Yeah, so, well, where I got this, that guy ran it against a flaws account. So it is flawed by nature, but it tells you which service or technology by Amazon, which account, the account type, and it also tells you generally what it thinks is wrong. So it's a great starting point to look at things. Prowler, I've also talked about, uses kind of the same code that the CLI uses to interrogate your IAM credentials and some of your services. And there we go. Sorry, the wrong title, but it was Zap. You can use Jenkins or Travis CI and set up. You can record vulnerabilities you've seen in the past, and you can script it as well. So it has Python, Java, JavaScript plugins, and that's.
Have you heard of Ghostwriter? Tool was released recently with the military S3 multiple buckets.
No, not yet.
Check that out. It's quite scary.
That's probably, if I remember correctly, that's why Amazon started showing the public.
Yeah.
So Ghostwriter happened, and then they had to do a full review of S3. So I did look at S3 a lot, but it wasn't the only thing I always focused on. S3 is kind of the low-hanging fruit, and then other services. Like S3 was, the problem generally is with cloud infrastructure that because you can't take away access to devs and everybody, you can do everything that you want, you can lock everything down, but at some point someone's going to unlock something again or create a new bucket. So these tools help you to generally just get an overview before you even go and look, because just by just looking at it and doing sort of a look through there's so many screens to go through in the console and AWS. To have a starting point is huge. And more questions rather.
What's a VPC? Is that a virtual private container or something?
No, it's a virtual network essentially. They call it a
It is a virtual private circuit.
They call it a virtual private cloud.
Oh, cloud.
So generally, everything that should encapsulate your services. So when you usually start on AWS or you launch anything, there's a default one that they give you, default pretty much everything. But generally, you need to go look and lock things down. But think about it as 10.0.0.0.1 dash, like the whole range, and then you go break it up into subnets, and then you put your services in the subnets. But it's essentially your own NAT. It's a NAT they create for you, and all your services live in there, and everything ingresses and egresses through it. But then you can go even further and create multiple, and then route in between them. So for instance, Lambda, we didn't want it directly in the same VPC, so we created a separate VPC just for Lambda, especially because Lambda gets very parallel and they generally attach a IP to each container. If it went massive and we had a lot of services, at some point we would run out of IPs at that moment to use. So you generally separate it, but it's also a security concern because you could have separate rules and then only route to one service on the other side. It's generally what we did. Anyone else? AWS is expensive, just remember that. But generally, all the kind of good security things are mostly free, so use them. WAF is not free, and networking. The funny thing is a lot of the security things also make it somewhat cheaper. If you're not routing all your traffic outside of the network, you don't get charged for it, or less. So funny enough, sometimes the security makes it cheaper or more expensive depending on what you're doing. I'm trying to think what else we did. Obviously patching and hardening the actual Ubuntu images that they have. Generally it's quite solid, but you can add a little bit to it. Don't have port 22 open to the world. You'd think that's quite obvious, but then someone goes, yeah, but I can't hit my SQL from home. Well, have you used the VPN? No, because I broke my DNS settings on my Ubuntu. Okay, cool. So fix the DNS problem, and then we'll talk again.
Cool. Thanks.